Hey everybody, this is Alex Merced, and you're listening to my tech podcast. Okay, basically I've consolidated all my podcasts into just sort of one stream. So regardless of what you're subscribed to, you're going to get the same episodes. Where I just talk about technology, whether it's data, whether it's web, whether it's handheld gaming, whatever the like. Just whatever sort of interesting me at the time that I decided to record an episode. And lately, for those who've been listening for like the last couple of years, it's generally going to be data. And what I want to talk about today is the idea of a universal catalog. Okay, so let's just first talk about the evolution of why you would want a universal catalog and why this is a problem to solve before we get into sort of what the potential solutions are. So essentially, when you think about just sort of what a catalog traditionally was, it was just a piece of the puzzle in building a database or data warehouse system. Because essentially the idea is that when you built a database or data warehouse system, you were building this sort of completely integrated system that would handle everything you need to store, govern, and query data. Okay, so essentially, a database like Postgres or a data warehouse like Snowflake, they would handle how they store the data. They would understand how they know which data belongs to which data set, which table. They would understand the listing or which tables existed and who has access to them, the catalog piece. And then there'd be a processing layer for which you could submit queries, usually via SQL or structured query language, or SQL, depending how you want to say it. And then the engine would then basically take that SQL query, break it down to an abstract syntax tree, then parse that abstract syntax tree, turn it into an execution plan of how it's going to actually find the data and process the data, and then actually execute that execution plan. Okay, so that's essentially how your traditional database data warehouse system worked. It was all in a box. Okay, which was fine for a long time. I mean, basically the velocity at which we needed to work with data was at a pace where, basically at a lower scale, one database or data warehouse system can oftentimes serve the vast majority of your use cases. And that's still the case, again, for a lot of smaller use cases. There's people who literally will operate just off a Postgres or a SQL server for transactions and analytics for a very long time. Okay, and that's enough. And then that's fine. But you get to a point where transactional queries don't really work very well. I mean, not transactional queries. Analytical queries don't really work well in transactional systems like SQL Server and Postgres and MySQL. So then you start moving that data over to an analytical system, a data warehouse. But again, right now you have to move the data because they speak a different way. And I mean, that's still the case for transactional versus analytical, but the idea is, hey, you've just now had to do this movement of data, oftentimes referred to as ETL. You're exporting the data. You might have to make some changes to it, aka transform the data, and then you load it into a new system, the L. Okay? So you've now moved the data from one system to the next, and the target system, great. The problem is analytics has gotten much more complicated, okay? Also, as companies have gotten bigger, oftentimes you have different departments with different analytical systems. So you end up in the situation where you had what's called a silo, where basically you have different data in different places with different rules controlled by different people. So when you're trying to build enterprise-wide different types of analytics, whether you're building a dashboard, an AI agent, or just trying to put together a report of what's going on in the company, getting access to the data you needed was real problematic. Okay, and there's different ways you can solve this. Okay, this is definitely something that is constantly on the mind of us at Dremio. For those who don't know, I am the head of DevRel at Dremio. Is the idea of like, how do you break down these silos? Whether it's through query federation, a feature that Dremio has, which allows you to run queries across different sources, so that way you don't have to worry about where the data is at. But more of a consensus lately, not just because it allows you to access the data, but also because it makes oftentimes will save you money. Operationally and a variety of other benefits, is the concept of a data lakehouse, which is another thing that Dremio in many ways serves. Okay, and the idea here is that you take most of those relational data sets, those columnar data sets, and that structured data, and put that into a standard format. And the industry standards kind of become Apache Iceberg, which just means that you have this layer of metadata on top of your data files, which are typically stored as Apache Parquet files, which is a file type specifically created for analytics. So the idea here is you have these really fast tables that are not stored in a particular system. They're not stored in a Postgres or a Snowflake. They're independent. Okay, yet both Postgres and Snowflake could then query that table. Okay, so you're not having to move the data across multiple systems. Okay, whether it's Dremio, Trino, Snowflake, Google BigQuery, Microsoft Fabric, all these different sort of tools and platforms can speak Iceberg. Okay, AWS with Athena, etc. They can all talk Iceberg. So in this case, you can use multiple tools, and different departments can use multiple tools without them having to recopy the same data. So that's sort of what we get. So this whole move to saying, hey, you know what? Let's just store everything in the data lake being typically object storage. So think of your Amazon S3, your ADLSs, saying, hey, let's just store all the data as files. And then the data lake house, using something like Apache Iceberg to say, hey, let's treat those groups of files as tables, allowed people to really start using their data lake as their data warehouse, thus the term data lake house. And this works phenomenal. Okay, you're starting to see much more people moving over to Apache Iceberg data lake houses and migrating over. And basically, one of the questions that came up was this whole idea of catalog. How do I track these tables and govern them? And you had a lot of different types of catalogs you could use with Apache Iceberg tables, which created fragmentation because not every catalog worked with every tool. So to fix this problem, there was a standard that came out called the Apache Iceberg REST catalog standard that created a standard API that allowed every tool to say, hey, long as the catalog I'm talking to follows this contract, I'll know how to, and I understand the contract, I can talk to that catalog and I can understand the responses from that catalog, allowing there to be sort of universality in being able to use Iceberg with pretty much any catalog. So whether I'm using something like an Apache Polaris, Unity catalog, Data Hub has an Iceberg catalog now. Everyone has an Iceberg catalog these days. Whether it's AWS Glue or AWS S3 tables, MinIO's new AI store tables, whatever it is, any tool can talk to it. So Dremio could talk to it. Let's theoretically any of these tools using that Iceberg REST catalog interface, because you just use a standard way of connecting. Okay, but that works phenomenal and creates universality for Iceberg tables. What about things that are not Iceberg tables? Whether there may be reasons you have Delta Lake datasets or Hoodie datasets or Pymon datasets, or even beyond structured data, you might have PDFs, images, whatnot. These are datasets you're still going to want to be able to know where they exist, and two, you're going to be able to want to control who has access to them without having to give everybody direct access to your object storage. Okay, so it'd be nice to have this catalog that acts as the middleman between people who need data and access to that data where it is. And right now you have this fragmented world where basically everyone agrees on how they handle Iceberg tables, but very little else. Okay, so if you want to track anything else in your catalog, the catalog may not be able to track that yet, and how it tracks that may not be usable by other tools. So it doesn't really help you much. So this is why this journey of a universal catalog matters. Okay, we have now data sets that allow us to kind of break free of these sort of integrated data warehouse and database and data warehouses, but we still want to create a system that can track every type of data set and say who has access to it. And basically, I wrote an article on this topic, and generally the way I see it, there's going to be 3 paths. In the article, I talk about 2 paths, but I thought of a third one right afterwards, so I'm going to talk about that as well. And essentially, the idea is there has to be some sort of standard way to talk to non-Iceberg data sets that gets established. Okay? So that way, because at the end of the day, like, there's lots of tools. Okay? You think about, like, different engines. There's, like, Dremio. There's every data warehouse has their own engine. So Snowflake, Redshift, Trino, which powers Athena. You have Microsoft Fabric, which leverages Spark, and Databricks, which leverages Spark. You have Data Fusion as a open engine, really kind of being out there, and DuckDB, StarRocks, Doris. There's a lot of different engines out there. So in that case, in this sort of lakehouse future, you would have to, if every catalog is going to have its own API for not Iceberg stuff, you're telling all those engines that they would have to implement support for those APIs for every catalog, and then maintain those API, maintain those integrations as those catalogs change. That's a tall order. This is the reason why there was a table format war, because it was a lot of work for every tool to support every format. Okay, it's not just as easy as just dropping a jar in your project. There's a lot to it. Okay, so the question becomes, how do we get to that standard API? Okay, and I can think of three paths. Okay, path number one is that and this is the path I think is most likely to happen, is that a catalog implementation becomes a standard. Okay, now the question is sort of which catalog implementation. So when you think of catalog implementations, like there's the vendor-based catalogs, particularly the three major clouds, which would be like AWS Glue, Big Lake, One Lake, and then there is there's Unity Catalog, the Databricks platform version, and then when you think of open catalogs, you have like Apache Polaris, Apache Gravitino, Lakekeeper, Nessie, and the open source version of Unity Catalog, which is technically a separate code base and not exactly parity on features. Okay, always gets confusing with, same thing happened with Delta Lake, where there was like Delta Lake OSS and Databricks Delta Lake, and sort of what features you had where. It gets confusing. I'll come back to that. But essentially, you have these two paradigms. So the question is, first, like, if an implementation is going to become the standard, is it going to be a vendor implementation or an open implementation? Now, we've seen examples of both. Okay, when it came to object storages and how object storages work, S3 became the standard object storage because it existed pretty much before everyone else, and because of that, it became the decider of how you talk to object storages. Because at the end of the day, like, while there are alternatives like Google and Azure have their own object storage APIs, most other entrants don't have necessarily the gravity or adoption to sit there and say, hey, all these other tools need to build support for how to talk to my particular object storage platform. So then they adopt the S3 APIs. They say, okay, hey, we talk the same way that S3 talks, so your tool that talks to S3 can talk to us too. Okay? The problem is that S3 API is controlled by AWS, which means that some other vendor, who's technically your competitor, controls your development road path. Okay, they change their API, you have to update your API, because every other tool is going to update the API, and then if you don't stay up to date, then your other tools support for you break. Okay, now that's the case with any API, that you have to stay up to date with it. The difference here is that another vendor is in control of it, and they can change it in ways that are completely, and contradictory to sort of your business roadmap, and then that just puts you in a precarious position, and there's nothing you can really do about it. You just have to work around it. Okay, so I think the industry kind of learned from that and saying, okay, hey, we don't really want that to happen again. Like, it happened, it's fine, we're glad that there's a standard API, but it would be nice if it was like a more community-oriented API. So when it came to the table format wars, I think the reason why you had such a groundswell of support for Iceberg was the fear that you end up with another sort of vendor-driven standard that makes everybody else sort of, have to sort of play second fiddle to another vendor who can basically break your product at the drop of a dime by changing these APIs without really any true feedback loop. Okay? Beyond their internal roadmaps for their particular sort of goals. So Iceberg ends up winning. So in that regards, that to me takes all the vendor catalogs off the map. I don't think they're necessarily going to go anywhere, but I don't think any of them are going to become the ubiquitous standard. I mean, you already see, anything Amazon does is going to be a standard to some extent. So AWS Glue is a standard to some extent, and you have seen people leverage the Glue APIs as a way to build their catalog products on. Particularly, this is sort of the approach that Starburst has taken for their catalog product, where instead of building on the Iceberg REST API, they've decided to build on the Glue API, which there's reasons to do that. Again, it's essentially the Glue API is essentially a take on the Hive API, and there's pros and cons. I'm not going to really get into that because that's not the point of this particular episode. So theoretically, yeah, there is anything AWS does is a standard API just because of the ubiquity of the usage of AWS. But it doesn't necessarily mean that there isn't a demand for a industry standard that is, again, vendor agnostic. Another reason why I don't think the Unity catalog will become the standard either, because even if it is a Linux, the OSS version is a Linux Foundation project, same thing with Delta Lake. At the end of the day, like generally the roadmap, the steering of those projects are still very much Databricks. Again, that's not a knock on Databricks. Okay, again, that allows Databricks to move faster and iterate faster. But at the end of the day, then everybody else embracing that as a standard, then creates the same situation as I mentioned earlier with S3. So when you take a look at the sort of others, you have Apache Polaris, Apache Gravitino, and a Lakekeeper. And probably the most vendor agnostic-y one is going to be Apache Polaris, which is an incubating Apache project. So is Gravitino. I mean, Gravitino is now a top-level project. But you have some pretty big firepower behind Polaris. I mean, you already have different productizations by multiple vendors of Apache Polaris and more coming. So you have, Snowflake with Open Catalog, you have Dremio with Dremio Catalog, all productizing Apache Polaris into the product, along with the ability for you to deploy it yourself. And then there's been pretty active development in Polaris. Okay, so to me, like if this is the path that's going to happen, my prediction is Polaris becomes there just is going to be the demand for that community standard. Polaris is going to be the path of least friction at this point. Has the most development. It's community driven. People can submit their pull requests. Everyone has a say. Everyone can be part of the conversation. So it just seems like the most vendor neutral place to go build a thing that the whole industry can use. And then once that gets the adoption over the next couple of years, that I'm pretty sure it will get, then its APIs will become the standard that everyone else begins to build on. Okay, this is, again, a longer term vision, but that's how I see that path. Again, when I take a look at all the different options and the reasons why, again, because it's not just about, hey, is it the best one with the most features? All these things are going to eventually have all the features over time. That's, anything good that Polaris does, Unity is going to copy. Anything good that Unity does, Polaris is going to copy, probably in different ways. But at the end of the day, like the features will exist. The question is sort of like, where am I going to have the interoperability in the long run, so that way I can take advantage of as much of my data in one place as possible. Okay, so that's path number one. So this is going to be a longer episode. Path number two is to extend the REST catalog API. Okay, so in this version is we leverage, what we do is, the thought process is to separate scan planning from the engine. This is already something that can happen on the read side. So in the Apache Iceberg REST spec, there's a thing called the REST scanning, the scan planning endpoint. And what this does is that traditionally when I scan an Iceberg table, the engine, let's say Dremio, is going to go, hey, I'm looking for a sales table. And then the engine's going to be like, oh, okay. I mean, the catalog's going to be like, yeah, okay, I know where the sales table is. Let me just check, make sure that you are allowed to access the sales table. Oh, you are. Wonderful. Here's the, object storage address for where you can find the metadata.json that's current for that particular table. Then Dremio would go read that metadata.json, which would allow it to discover the manifest list for the snapshot it wants to scan, and then discover the manifest detailing the different files in that table. And then it would figure out which files it wants to scan from there. So that would be sort of the path. So every engine is going to do that. So essentially there's two layers of planning. There's the planning of which files to scan, that's reading through the metadata. And then there's the actual execution of scanning the files and breaking up how I'm going to work with those files, the actual query execution. Okay, so right now the engine is doing both. They're doing the scan planning and they're doing the query planning and execution. Okay, the scan planning endpoint essentially separates that. Says, you know what? How about we let the catalog handle the scan planning part? So in that case, as far as all the reading of the metadata, determining which files, and just let the catalog give you back a list of Parquet files to scan, and then you take it from there, engine. Okay, and this gives a bunch of different possibilities. It was originally proposed by AWS. They use it to there's a couple different ways you can use this. Okay, First way you can use this is you can use it to allow other non-Iceberg things to be scanned. Because if the engine only cares about the Parquet files it needs to read, it doesn't need to know how you came up with that list. So theoretically, if the table was like a hoodie table, a Paimon table, a Delta Lake table, the catalog could traverse the metadata, come up with the list of Parquet files to scan, return the list regardless, long as the catalog understands the metadata format. Okay, the engine doesn't care because it doesn't do that part. It's only handling the list of Parquet files at the end. 2, it could allow non-data lake sources to be scanned. The way this has been done is that I would go, Dremio would say, hey, I want to scan, XYZ. And then under the hood, the catalog will push down that request to another thing like a Postgres database, Redshift, SQL Server, whatever. Run the query, get the results, persist the results as a Parquet file, and then return that Parquet file as the thing to scan. Okay? And essentially, it would just scan and realize, oh, these are the results. I'm not a huge fan of that approach, but theoretically you could do that. You could also use it for like optimizations. So maybe the catalog, instead of having to traverse all the file metadata by making round trips to object storage, it can create its own caching mechanism where basically when a write comes in, so essentially on the right side, what happens is it's going to be told that, hey, there's this metadata, but behind the scenes, the catalog could then go read the table, cache the metadata into a database, and then you leverage that database to do the scan planning so it doesn't have to keep making round trips to the object storage. Okay, so I can imagine something like, hey, I'm creating a SQLite for each table where I cache the metadata. So essentially every time a new commit comes in for that table, the catalog goes in there and reads the table, caches the metadata in the SQLite database, and essentially, it can then always use this, basically using the scan planning endpoint, it would just use that SQLite database to do the scan planning, and then again return the list of Parquet files over to the engine. So there's different ways it can theoretically be used, but a couple caveats. There's nothing like this on the right side. Okay, so you're still on the right side. Things have to be done sort of the traditional Iceberg way, where the engine's going to write the data, then the engine's going to write the metadata on that data, and then update the catalog and say, hey, catalog, just so you know, going forward, here's where the metadata is for this table. And then the catalog would update itself internally to say, okay, going forward, this table points to this location. So what you could do is you could add a scan planning endpoint on the right side, where essentially all that happens, instead of telling the catalog where the new metadata is, it just sends the catalog the information it needs to generate the metadata. So it'll give it like the table name, the type of table, like Iceberg table, Delta table, whatever, and then the table statistics. So like, here's a list of files, here's the stats on each file, and then the catalog would take it from there. The catalog would then take this list, all this metadata that you've just sent over the wire, write the metadata files in whichever format it prefers, or just write it directly to a database if you want to take sort of the more Duck Lake approach, and then commit in whatever mechanism it chooses to do so. Again, the idea is that the implementation details are going to be catalog specific and not matter to the engine. Okay? So then basically the metadata handling is all catalog stuff, and then the engines are just worrying about sort of scanning, getting access to the data files, and then scanning the data files and doing that last mile of query execution. Okay? And that's all well and good. Now the problem with this approach is that it puts more burden on the catalog. So now the catalog is doing a lot more work. And if you're having a lot of concurrent transactions or really large tables with lots of metadata, this can raise questions for how do you do this? How do you scale this? Okay? Or what is the required sort of, what becomes the cost of scaling up the catalog to handle this level of scale at very large scale? Again, that's just going to be a catalog consideration. But again, now when you're designing these catalog services, that becomes more and more of a consideration versus the catalog being a merely, hey, you asked for this name, I return you this address. Oh, you gave me this address, I update this entry in my back end. where it's, it can handle a lot of concurrent transactions very quickly because it's doing something so small. And this is kind of different than sort of where Polaris is going, because Polaris, where it's going, is they have this proposal called table sources, where essentially the catalog is going to be aware of the type of data source, of the type of data source, but all the metadata handling for other non-Iceberg sources will then be delegated to external services. So the idea is that if you want to handle Delta Lake or Paimon, you can have this external sort of metadata services external to the catalog that the catalog knows how to talk to for handling it. So essentially, you're passing off to sort of this like third-party thing or this other thing. So you're not putting that burden on the catalog. So the catalog can expand. In this case, Polaris can expand, hey, what type of data sets it has. But, the engine might act as that third-party service, or there might just be this sort of independent sort of metadata service that kind of handles a lot of that stuff. So, there's room for more sort of modularity there. Overall, I think it's a pretty good proposal. Again, it's generally why I think that's probably most likely what'll work out in the long run. And then the third proposal is not to do either. Okay, the third proposal is like right now there's another conversation going on in the Iceberg community about a file API. So what this would do is allow pretty much you using any file type with Apache Iceberg, because what you do is that essentially instead of having to come up, like right now, if you want to add like another file type, you need to come up with new readers and writers, okay, that then generate the statistics you need for the Iceberg metadata. Okay. So the way I understand the file API is to kind of come up with a standard for how Iceberg metadata, like how the type of metadata that Iceberg needs to collect. So that way, regardless of what file type you're using, long as you pass in the right sort of like statistics, the metadata can be written regardless of the file type, in a sense. But theoretically, you could start seeing this kind of evolve to where, and you can also just see Iceberg metadata evolving, where Iceberg metadata might have, key value pairs in the metadata that allow it to signify that it's something other than a relational table, like basically like an unstructured data set. And you can still have snapshots that are just basically like I can imagine like Iceberg table, and you have a version called unstructured data would be sort of a key value pair in that metadata.json. And when it is, you're just going to have a snapshot of list of files. So basically, in that case, instead of having all this complex partitioning and manifest, because you wouldn't really have that for like, let's say photos, it would just be sort of like different manifests pointing with a different list of, hey, these are the photos today. I've added a few more photos. I created a new snapshot. And essentially you still have that snapshot isolation. You still have metadata history. Apache Iceberg ends up still working fundamentally the same way, except now it's for tracking like unstructured data. Okay. And you have, and then essentially, again, there would just be signals in the metadata saying, hey, this is not a traditional relational data set. This is an unstructured data set, but here's a snapshot history, and each snapshot history having like manifest pointing to a list of files, allowing for discovery of that. And maybe even some metadata for different, again, types of use cases. There might be metadata you would want on a PDF file, or metadata you would want on photos. And those would be things that can be sort of figured out over time. Again, you'd have to kind of standardize that, and there'd have to be someone who figures out those standards. But it wouldn't be too hard to like put a signal in the Iceberg metadata saying that, hey, this is not a traditional Iceberg table, this is something else. So then the catalog doesn't really have to track it any differently. The way you update the catalog. So again, then the other two methods become less necessary because it's being handled in the metadata.json, distinguishing that it's something else versus it being handled by either placing the burden on the catalog or placing the burden on some external service of understanding these things. The engine would just be like, okay, hey, I understand this kind of thing, so in this case I'll proceed. If not, the engine can be like, okay, I don't understand this type of Iceberg table, we don't have support for table type photos or something like that. So these are the different paths that you can kind of see where standards come up with how technologically our tools can all interop to discover a way to kind of, again, take our listing of data lake assets or data lake assets, provide consistency, governance, okay, across the lake house. So take this as you will. Chances are you'll see a little bit of all three of these things come in the future, and the ending result might be a hybrid of the three. That's so technically that's a fourth path. But hopefully you guys enjoyed this. My name is Alex Merced, head of DevRel at Dremio currently. You can find the books that I've written over there at alexmerced.com, where you can download them for free. Apache Iceberg, the definitive guide. Apache Polaris, the definitive guide. If you haven't registered for Dremio's Subsurface Conference this year, head over to dremio.com/subsurface to register, especially if you're in the Bay Area or New York, where we're going to have 2 stops there. It's going to be good times. I'll see you all later. Have a great day and enjoy.